is chapter 18, set B, number 5. Okay, basically we want to toss a coin 10,000 times, and we're looking for the chance of 4,900 to 5,050 heads. Okay, so we're looking for a chance, and it looks like we're kind of counting how many heads. So we're looking for a chance, we're looking for counting. That means we're doing everything from chapter 17. We're going to have to put up a box model. We're going to have to find eventually find the expected value and standard error so we can find a chance. Okay, let's start with our box. So we're doing something 10,000 times. So we're going to do 10,000 draws from the box. So we're going to make our box. Now, what's in the box? Basically, we're just trying to count how many heads we get. So if you get a heads, we'll put a 1 for what we want, which is heads, and we'll put a 0 for everything else, or in this case, that would just be tails. Now, heads and tails are equally likely, so you could do like 50 heads and 50 tails, but really it's easy to just do 1 head, 1 tail, because they're equally likely. Okay, so 1 head, 1 tail. Now, the average of the box, well, we just add them together, so it's going to be 1 plus 0 divided by how many there are of 2, so 1/2. The standard deviation of the box, remember we always use this shortcut formula if you only have 2 things in the box. In our case, we have 1s and 0s, so only 2 kinds of things. So it's big number minus small number. I find it useful to write out these formulas every single time I do them, just help me memorize them. Times the square root of the fraction of a big number times the fraction of the small number. So the big number, the 2 numbers in there are 1s and 0s. So a 1 is the bigger number. So we'll do 1 minus 0 times square root. Now fraction of the big number, there's only 2 tickets in there. So just 1 out of 2 for the heads and 1 out of 2 for the tails, or 1/2 times 1/2. If you switch up these fractions, it doesn't really matter what order because of the properties of multiplication. So that does kind of help. You don't really have to keep these fractions in the right order. So that should just give me 1/2. Okay, it's just coincidence. The average is the same as the SD. Just coincidence. Okay, so we did our box. We found the average of the box, SD of the box. Then we find expected value of the sum, because the way we count is we draw 10,000 times and add up how many 1s we got. That's how we count. So we'll do the number of draws times the average of the box. So we're drawing 10,000 times the average of 1/2 means we're expecting to get about 5,000. That makes sense, right? Heads and tails are equally likely. We should get about half heads. Standard error in the sum will be square root of the number of draws times the standard deviation of the box. So we'll do square root of 10,000 times the standard deviation of the box, which is 1/2. Now make sure only the 10,000 goes in the square root. The 1/2 is outside the square root. You should get 50. Okay, so we know that when we do this, we expect about 5,000 heads, plus or minus 50 or so. So give or take 50 heads. So we're finding the chance eventually that we go from 4,900 to 5,050. Well, to get up to like 5,050, that's pretty likely because we expect about 5,000 heads, give or take 50 heads. So I'm guessing this overall chance is going to be pretty good. Okay. But anytime you want to find the chance for sum, you're going to use the normal table. Okay. And we have to standardize to find a z-value. So we do the sum we're interested in minus the expected value of the sum over the standard error of the sum. So we're looking for 4,900 to 5,050. There's 2 values. We're going to do each one separately. So let's do the 4,900 first. Doesn't matter which one you do first. You just have to do them both separately. So we'll do 4,900 minus our expected value of 5,000 over the standard error of 50 should give me negative 2. So that's my first z-value. My other z-value is going to be 5,050 minus 5,000 over 50, which gives me 1. So basically, if I was to draw my picture, here's my negative 2, z equals negative 2. Here's my z equals 1, and I want the area in between. Now, the area in between is tricky to find on our normal table. So what we're going to do is we're going to pull up the normal table and look for z equals negative 2. So when I look for z equals negative 2, it gives me an area of 2.28%, but that's going to be the area from it over to the left. So that's 2.28%. If I look up a positive one, I get 84.13%. So let's go back to my work. So basically it said from negative 2 over is 2.28%. And from 1 all the way over is 84.13%. Now neither of those numbers are what I actually wanted. What did I want? I wanted the area in the middle. So to get that, if I take the big area and subtract the small area from the tail, it'll give me just what's left in the middle. So the chance that I was looking for is going to be 84.13% minus 2.28%, which should give me 81.85%. Now keep in mind the textbook does round a little bit, so they'll probably round that to about 82%. That's fine, they just like to round.